So for today, you guys are going to be doing your first set of calculations. So just a quick recap on what was covered yesterday. You had a video that explained to you what the electromagnetic spectrum was, and so you got to see all the different parts of it. And the important thing that you should have grabbed from yesterday was the fact that the all these values are ranging from either the longer to shorter wavelength or from low to high frequency and low to high energy. And so knowing that, a couple things that you should have started making connections on is that the increasing wavelength associated with a decreasing frequency or decreasing energy, that is a indirect relationship, whereas frequency and energy show a direct relationship, as in this one goes down, this one also goes down. These are opposites, these are always the same. So make sure you have that connection. Another important thing to kind of realize, because you might see it today, is that light, all of the things on the spectrum, whether it's a radio wave or it's a gamma wave, all of those things are going to be traveling at the speed of light, which is 3 times 10 to the 8th meters per second, which is really, 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 really fast if you think about it. It's that many meters every single second. So for today, you guys are going to be covering the calculations. And so we're going to go over what these different things are, but you can see in red, you have variables. In blue, you have 2 constants that you'll be using. And in green are all of your different units that you'll want to pay attention to. So to start us out, we're going to go ahead and fill in these little notes so you can fill them in on your own. But we have 2 formulas. We have C equals, and this is a lambda. This upside down Y is called a lambda. This is an F for frequency. And then we're going to have E equals HF. So filling this in, your C is representing the speed of light, kind of what I just said on that last slide here. There we go. All right, so speed of light, and that is going to be 3 times 10 to the 8th. It's a positive 8, meaning a big number, meters per second. Then we have lambda. So this is lambda. This is going to represent wavelength. So when you go to draw lambda, I just do a Y, an upside down Y, and that's the best way to kind of make it show up. Then we have F. F is going to be frequency. Okay. So one thing I want to point out is that for speed of light, we have meters per second. For wavelength, we're measuring it in meters. And for frequency, we have hertz, or it could be 1 per second. So frequency is talking about how often your wavelengths are occurring, okay? That's why we say per second. It has 15 times per second, okay? All right, over here for the other formula, we have E equals HF. So E is going to be energy. And F is going to be still frequency, and H is our other constant. So we have 2 constants that we're looking at. This one is Planck's constant. Max Planck worked with Einstein in quantifying light energy, basically. So his constant and the speed of light constant are the only 2 that you gotta make sure you are never, ever, ever, ever solving for. So please never solve for H, never solve for C. You use these in order to help you find your missing piece. So you can see that we do have the ability to use the triangle still. So in the couple examples that I'm gonna do, I'm gonna be using the triangle again. So if we are solving for something like frequency, I'm going to cover up frequency and I'm left with C divided by lambda. So speed of light divided by wavelength. If I do the other one, we have speed of light divided by frequency. We will never put this on the C. C is 3 times 10 to the 8th meters per second. Same thing with the other formula that you have here. Another thing I want to make note of before we go and look at a couple practice problems is you should have a calculator pulled up right now. And I recommend you just go to Google, type in calculator, you have your little calculator right there. So when you go to type in something like the speed of light, who is 3 times 10 to the 8th, don't type in times 10 to the 8th. Just don't do that. It's going to mess up some of your calculations. So what I recommend, you do 3, you're going to push this exponent, you push 8, and now you can divide it by whatever you need to do it, or you need to multiply or add or whatever, okay? So that is going to be how you type that one in. Now, if I wanted to do hold on. There you go. If I wanted to do Planck's constant, I have 6.63. I'm going to type that exponent. You're going to use the negative 34, and you'll still get the same value. Okay, and you can see that it changed it to a little lowercase e. So again, use the button that says EXP. Okay, all right, so let's go ahead and do a couple of these practice calculations. So oh, I forgot to mention one other thing that you could possibly see is sometimes you have the situation where you're given energy and you're wanting to know wavelength, or you're given wavelength and you want to know energy. Okay, so the way that you're going to be handling this is you're going to be referring to the connection point, which was um, the fact that both of these things involve frequency. They both are related by frequency. So because of that, we can now rely on this other formula that uses that idea of going through frequency, and you have energy is equal to speed of light times Planck's constant, all divided by wavelength. So we might have a problem that is going to involve that one. Okay. All right. So our first problem that we're going to solve right now is going to be calculate the wavelength of a photon of light whose frequency is 4.50 times 10 to the 14 hertz. So looking at the first piece of information that was given to us, we have calculate the wavelength of a photon. So calculate the wavelength tells us that that's what we're solving for. So when we're listing out our givens, we're going to put lambda with a little question mark. Then we have frequency. We're going to write out that number. We have 4.50 times 10 to the 14th hertz. Okay, so again, this is their variable. This is our unit. All right, now we're going to figure out which formula is best to use. So looking at these two formulas, okay, we're going to kind of do a little checklist. So I see that I have a lambda. So if we have a lambda and we have a frequency, we're looking down here, which one has both of those? And the correct answer is going to be the C equals lambda times frequency. So that's going to be the formula that we're going to use. But as you can see, it's set up to be equal to the speed of light. That is not how we want to be solving for things. So we're going to use our little triangle method. Okay. And since we're solving for lambda, we're going to cover up that value in the triangle. And now we're left with C divided by F. So now that we have that, we can go ahead and start plugging in. So we have lambda is equal to C divided by F. Now we can plug in what we have. So C is just going to be our speed of light constant, 3 times 10 to the 8th. And F is going to be what was given to us in the problem, 4.5 times 10 to the 14th. And we're going to plug this into our calculator. So we have 3E8 divided by 4.5 E14 equals. And so we're given a value like that. Okay, and if you type it into a different calculator, you might get all the zeros that that represents, right? Because we learned last week that this E to the negative 7 or times 10 to the negative 7 means that we're adding a bunch of zeros beforehand to make it a smaller than 1 number. So now that we have it in what we wanted in, which is shown over here on the calculator, we got to figure out how many digits we're going to be doing that to. So looking back at our problem again, okay, we are going to figure out, looking up here, that we want 3 significant figures in our answer, okay? And actually, because I kind of changed it down here, I have 2 right here, and so we're going to have 6.7 times 10 to the negative 7. Okay, and we're going to follow up with meters for the units. So the next problem we have is calculate the frequency of a yellow light whose wavelength is 4.2 times 10 to the negative 7 meters. So looking again, we have calculate the frequency, so that's going to be what we're solving for. So we put F is equal to question mark. We have a wavelength of 4.2 times 10 to the negative 7 meters. And we got to figure out again what is going to be the best formula for us to use. So looking here, we have C is equal to lambda F, and we have E is equal to HF. So looking at what we're given, we have a lambda and we have an F. So that means that this is going to be our best formula to use again. So we're going to set ourselves up. Then we're going to do our little thinking work because we want to solve for frequency this time. So using our little triangle method, we're going to cover up frequency. And we see that we're left with speed of light divided by wavelength. So with that, we're going to set ourselves up like that. And we are going to start plugging in the values that we have. So again, this 3 times 10 to the 8th, it is coming from the fact that we had our two constants, right? So remember, these are your constants. You're going to be using them. And so back to this. Now we're going to plug in the value that was given to us in the problem, 4.2 times 10 to the negative 7. When we plug this into our calculator, so again, let me show you that one more time to make sure you are plugging in correctly. So you have 3, you're going to push this exponent, 8 divided by 4.2 exponent negative 7, and we're going to push equals. And so we get this value. So looking back at the problem, we were given 4.2, which was 2 significant figures. So because we have 2 significant figures, we have to go to this first decimal. So this would be first significant figure, second significant figure. So we're going to have 7.1 times 10 to the 14 hertz. And that is going to be your final answer for this problem. So finally, for this next problem, I'll kind of go through this a little bit quicker, is we have calculate the frequency of light if the energy is 4.7 times 10 to the negative 17. So we're given these two values. So when we have to decide which formula is best for us to use, we're going to do the checklist thing again. So we have F and we have E. So looking at that, our best option is using the E equals HF formula. We do notice, though, we're not solving for E again, so we got to figure out how are we going to arrange this formula. So looking at the triangle, we're going to cover up F because, again, in the problem, it's asking us to calculate frequency. So because we have F equals question mark, we're going to cover that up, and we end up having E divided by H. So knowing that, we're going to start plugging in our values. So from the problem, we were given that 4.7 times 10 to the negative 17 divided by, and remember, H is from our list of constants. So H is going to be this 6.63 times 10 to the negative 34. So that's a constant. And now we're going to type these into our calculator. And when you type it into your calculator, the way that we were in the other problems, we would be typing in 4.7 E negative 17 we're going to divide 6.63 E negative 34. And we end up getting this value. So you can see this has a positive exponent. That tells you it's a really big number, okay? So, and it kind of makes sense, right? If we're solving for frequency of something on the other end of that spectrum, those are high frequencies, okay? So knowing that, we're going to start writing our answer. And so we end up having 7.08 times 10 to the 16, but we only have 2 sig figs, so we're going to stop at the 0. We're going to round it up to 7.1 times 10 to the 16 hertz. Okay, for our last problem, we're going to look at a blue light has a wavelength of 4.34 times 10 to the negative 7 meters. Calculate the energy. So writing down the givens, I see that I have a wavelength of that, so I went ahead and wrote lambda 4.34 times 10 to the negative 7. And then I am going to write energy is equal to question mark. So looking at that, and if we do our check mark method, okay, we see that we have lambda and we have E. Those are not part of the same formula. So this is one of those where we have to use that special formula. E is equal to speed of light times Planck's constant, all divided by lambda. Okay, speed of light or times Planck's constant, all divided by that wavelength, and that's that connection. Because once again, we're going through frequency. Now, if this is really overwhelming using parentheses and things like that, solve for frequency, then solve for your energy. Okay, so you can also do it in 2 steps, and you can ask your teacher if you are having trouble with that. All right, so back to this. We're going to start plugging in what we've got. So our C is 3 times 10 to the 8th. We're going to be multiplying that value by Planck's constant, which is 6.63 times 10 to the negative 34. And then we're going to divide that whole thing by our lambda, or our wavelength, of 4.34 times 10 to the negative 7. So using our Google calculator, when we go to type this in, this is a little bit longer than the other problems that we have done so far. We are going to type in 3 times 10 to the 8th. We're going to multiply it by 6.63 times 10 to the negative 34. And at this point, I would push equals. So what we just did is we took care of that whole top line. Now I'm going to divide by the bottom line. So divide by 4.34. So we're down here. E negative 7. We're going to push equals again. So our final answer that we come up with is going to be that 4.5829 times 10 to the negative 19. And as you can see, since it has that negative exponent value, that means it's a tiny number. Okay, it's a very small number, which also makes sense. If you think about the energy in a little photon of light, it's really, really tiny. So, all right, so writing this, we will only have 3 significant figures. So we have to round it to these 3 values, these 3 non-zeros that we have. So that tells us that this little 2 is going to tell us to keep that the same. So when we go to write this final answer, it is going to show up as 4.58 times 10 to the negative 19. And our units on that is going to be joules. So hopefully that helps. Make sure you take care of your assignment today. It should look like this. And when you are actually zoomed into it, you will have a drag and drop that I want you to take care of. You'll have a triangle that you can type in your different variables. Use the notes from today. It's back on the video if you scroll kind of back to the beginning. And then you have these that you can attach your work either to the slideshow and send it back to us, or you can take a picture of your work and send it back.